And today he's going to talk to us about so-called Freudian speech errors. I'm sure it's going to be a really great, fascinating talk. And I won't waste any more of your time. Without any further ado, here we go.
Thanks very much. It's great to be here. I had no idea you had such an active undergrad cognitive science group. I mean, you are the engine of the creolization of cognitive science to the extent that it's going to happen. That's your responsibility. Do it. Make it happen. So, speaking of things that have helped make things happen, I've listed a lot of people up here. Many of you might know Susanna Gallo. She was involved in a lot of this. And I might not mention their names when it comes up, but they're here. So, Sigmund Freud. Sigmund Freud has always been the bad guy of psychology as far as my memory is concerned. We always told Freud to be the wrong person, the wrong way to do science. I mean, this is in academic psychology, not in the rest of the world, but in academic psychology. That's very much true. And this is filtering out into the real world. This is an article in the USA Today. Freud, so wrong and yet so right. He was far ahead of his ideas with some, far ahead of his time. What's a good one? Far ahead of his time with some ideas, but dead wrong on others. And kind of that's the theme of my talk, but I want to emphasize today what Freud got right about speech errors, because there's a lot of them. So, speech errors. I used to use George Bush, but I don't have to anymore, because our vice president is a very good source. I'm sure he doesn't mind me doing this. This one is a good one. It's one of my favorites. It's before he was vice president, it's when he was a senator. Many of us were in Rome at the president's funerals. Excuse me, Freudian slip. At the Pope's funeral that the president attended, substituting the word Pope with the word president. And naturally, you can see the press jumped all over him. I mean, Biden himself admitted it was a Freudian slip. He unconsciously wanted to be president and repressed the idea. And it slipped out. You know, that's the essence of Freudian slip. When he was running for vice president with Obama against John McCain, he made another one. John McCain. And then he also said, Freudian slip, folks, Freudian slip. And at this time, Biden is so famous that whenever he makes one of these slips and appeals to it, people wanted to know what he really meant by a Freudian slip. And at the time when he made the slip, Google searches just spiked. People said, what is a Freudian slip? What is a Freudian slip? So let us ask the master himself. A Freudian slip is when you say one thing, but you mean your mother. That's the essence of the Freudian slip. It is a speech error. It is an error in speech. It is not what you meant to say. But in the actual Freudian account of this, it is especially revealing of something that has been repressed. And it's the act of repressing that makes it want to sneak out in other ways, such as in speech. Freud got his start studying speech errors from another study of speech errors that came before him by Rudolf Mehringer, who was a linguist in Vienna, who recorded the errors that the people he ate lunch with made, and wrote a couple of books on them. Mehringer provided very good evidence for this claim. The properties of slips arise from the nature of language. And as a linguist, Maringer was well aware of this huge feature of language called duality of patterning, which the linguist will know, here will know what I'm talking about. Duality of patterning means that there's a different patterning of the way that words come together to make sentences from the way that sounds come together to make words. We have meaning-related patterns and sound-related patterns. And Maringer proposed that the speech production process goes from thought, can I get a pointer here? Yeah, thought to the meaning-related patterns, and after that to the sound-related patterns, and down to articulation. And the evidence for that is that we can get slips at each one of these stages. We can get word slips where we replace one word with another based on their meaning, such as Biden's confusing president and pope. And we can also have sound slips or phonological slips based on the sounds of words being substituted, misordered, and things like that. I had to throw in one bush, one Mississippi, one next Mississippi instead of Mississippi. Today, when we look at a model like this, what the field says is there's something right about this. This is correct. Today we would call this a top-down modular theory, top-down serial modular theory of speech production. And there's a great deal that's correct about this sort of thing. Freud read Maringer's paper and he didn't buy it. He thought it was wrong. And here's a quote. Freud said, what I find in slips of the tongue is not the influence of the contact effect of sounds, the sounds of words like next messages, but the influence of thoughts outside of the intended speech. Freud in particular thought that even phonological slips, such as next messages, were caused by something out there, deep in your mind. And another way to say this, a way to say this that's more kind of palatable, is even phonological slips express meaning. So was Freud right? Freud was right. Phonological slips express meaning. A just beautiful and incredibly simple experiment by Motley and Bars a long time ago demonstrated this. Subjects in their experiment were asked to say pairs of words like get one quickly. And if you schoonerize the initial consonants of that, you get wet gum. And this doesn't happen very often, but it can happen. But if earlier in the list of words you have to say, you happen to put the words damp rifle, it increases the chance of your making the phonological slip, get one slip into wet gum, by a factor of 2 or 3. So the day looks something like this. So if it's primed by damp rifle, the chance of the slip is a lot more. Phonological slips express meaning. Freud was right. Another principle. You've all heard of Freud's idea of the overdetermination of behavior. I really couldn't find a good quote, so I just made this up from pieces of things that he said. So this isn't a quote. No, there are no quotes, but basically, a single observed effect, such as a slip or a particular component of a dream, is usually determined by multiple causes at once, any one of which might be sufficient to cause that effect if strong enough. So a lot of times, small things gang up to cause the slip, small different kinds of things. Is Freud right? Yes. Freud's right again. Let's go back to Joe Biden. He said, oh, whoops, I'm going to get this one backwards the whole time. He said president instead of pope. Most people would think of that as a semantic slip. Presidents and popes are powerful offices. They're both extremely important powerful offices for Biden in particular. But they also both begin with pope. And so maybe that sort of helped the slip along. Maybe semantic and phonological similarity work together to cause these slips. So is this true? Are semantic slips also sensitive to phonological similarity? and they are. This can be seen in pretty much every category, every slips from basic individuals, slips in normal conversations, slips in experiments. You just see this. It's sometimes known as the mixed error effect. In our study of this, we gathered 197 semantic errors, and we simply asked, so these were errors in which one word replaced another word, like Pope and President, and we simply asked whether their initial segments matched, whether the second segments matched, and various other segments. So for example, in the case of Pope and President, we would get credit for there being a match on the first position, but a mismatch on the second position. And you can see it's not a giant effect, but there is a reasonably strong tendency for semantic word substitutions to match on the first segment, on the second segment. It goes out to about the third or the fourth segment in the word, compared with chance. And chance is a complicated thing. You can ask me about it, but I'm not going to explain it. There are people who know about mixed errors actually at one point several years ago made a prediction that a certain kind of mixed error would be very likely, and they were right. Here is everybody in my field predicted this mixed error would happen, and it did.
All I'm saying about the Patriot Act is that the elected representatives of this country, including Osama, Obama. I'm sorry.
So, you can find that video on YouTube. It has about 30 of them. So, this is the mother of all mixed errors. How do we think about this? Well, let's summarize what we've learned. Meaning influences phonological slips, and phonology influences semantic slips. If we just take Maringer's theory completely literally and go through a series of stages, like semantic stages, other stages, phonological stage, articulation in a strict top-down manner, we can't explain either of these things. What we have to do instead is borrow a very common idea in cognitive science from studies of language understanding and word recognition, just called interaction. That activation flows in both directions at once. So it's very, very common to speak of how our expectations of knowledge flow down to influence our perception. Well, the analog of that in production is that as we are, talking is a top-down process. But interaction means it's also a bottom-up process at the same time. So if we allow activation to spread in both directions, we can explain these phenomena. And we have done this by making a model of how we retrieve words when we speak. It's called the two-step interactive model of lexical access and production. I've been working on it a while, been changing it over the years, and I'm going to give you a very brief introduction to it. And I hope it's not too complex, but just, it's very simple ideas. Imagine all the words you know are in a layered network with semantic features, words, and phonological segments. And the crucial thing is that the connections run in both directions. It's an interactive model. So it's also a two-step model. This is an important idea that comes from language production theory, that retrieving a word has two steps. You first retrieve the word abstractly, and then you retrieve the actual phonological form of the word. It goes like this. So here's the first step. Where's the first step? So suppose you want to say what this thing is. I always use cat as an example. I really should stop that, but the slides are slides. So, you start out by activating semantic features. That activation flows throughout the network. And you complete the first step by selecting the most activated word in the proper syntactic category. If you're searching for nouns, you pick the most activated noun. So there, cat has been picked. We have finished the first step correctly. The second step begins by giving a big extra jolt of activation to cat, which for those of you who are interested in this, makes this into a nonlinear system with that extra jolt adds a big nonlinearity to the process. A big jolt to cat, the activation spreads around again, and we end up selecting the most activated segments. And hopefully we did that correctly. So those are the two steps involved. It's really very simple. You can program this in a program like that long. It's very, very simple. So why are there two steps? But there's a lot of reason for why there should be two steps, but the most intuitive is known as the tip of the tongue state. Everybody knows what the tip of the tongue state is. You're trying to remember something you can't. You know the word exists. If you're speaking a language with grammatical gender, you know the gender of the word. You just can't get its form. It's a remarkable effect. And that suggests that you can get stuck between the steps, between the first step and the second step. So I actually had this, going back to Joe Biden. I'm sort of obsessed with him because he was my senator for a long, well, I'm from the state of Delaware. It's a really small state. Joe Biden was the senator from Delaware. I actually knew him. I was a lifeguard at a swimming pool where he was the manager. It was a really small state. So I was trying to, somebody asked me what his middle name was, and I was trying to remember it. And I was in the tip of the tongue state. I knew what it was, but I was in the tip of the tongue state. So it's on the tip of my tongue, it starts with R, and it's funny. It doesn't sound like the rest of his names. It's just totally bizarre. And that's what I was able to get. Does anybody know? It's Robinette. What a name. Isn't that great? Okay. In this model, speech errors result because the spreading activation process activates a lot of material other than the intended material, and because the spreading activation process is stochastic, there's noise in it, there's a chance that you can make an error. So like a semantic error, like saying dog instead of cat, just happens. It's very straightforward, shared features. There's a chance that you'll say dog instead of cat. A little bit more interesting is what we call a formal error, like saying mat instead of cat. In this model, because it's interactive, has a somewhat strange explanation for these sorts of errors. When you say mat instead of cat, on the surface, that's kind of a weird thing to do, right? You choose words based on their meaning. It's reasonable you might make a mistake and say dog instead of cat. Well, why would you say mat instead of cat? Well, it has to do with the duality of patterning in language. And in this particular model, that comes out as when you're trying to say cat, the activation flows down to the sounds of the words and just follow the red lines. Because it goes back upwards as well, mat gets some activation and there's some chance that it might be chosen. Mixed errors, like the Obama case, are especially likely in this model because the top-down influence of shared semantic features and the bottom-up influence of shared phonological features converge to make errors such as rat instead of cat especially likely. So that's how this model explains the ubiquity of these mixed errors. And of course, you can also get errors in the second step where you might say dash or mat instead of cat. You correctly chose cat, but you mispronounced it in some way. So it's a very, very simple idea. Put this together in sentences. When we produce words in sentences, we're producing a sequence of words, so you have lexical retrieval events at multiple points in time. A lot of the slips of the tongue that we see happen when you get interference from words at different points in time. It's as if the words, the way I say it, slips happen when words collide. And if you're trying to say something like, what's my example? What am I trying to say? I'm trying to say cat in the font. Yeah, that's right. It's at the top there. But you might make a slip and say fat in the font because the activation pattern of cat is there, the activation pattern of fog is there, and they blend. They interfere with each other, you end up with fat, and this can be especially promoted if you're thinking about fat at the time, if that's a highly frequent word for you, an important concept. And now we're beginning to sound a little Freudian here. But that's how this sort of account works. It is Freudian in this respect. Oh, I'm just making things clear. Okay. Freud said something else about speech errors that I like. He talked about how speech errors result from brain damage. So, and he proposed, I'll just read it, the paraphasia in aphasic patients. And paraphasia just means a speech error made by somebody with aphasia. The paraphasia in aphasic patients does not differ from the incorrect use and distortion of words which the healthy person can observe in himself in states of fatigue or divided attention. In other words, the speech errors that we all make and the speech errors that the aphasic individuals make are really, they do not differ qualitatively. They just differ quantitatively. There's just a continuum between them, not a sort of a big difference. So is Freud right about that? Well, that's a harder question to answer, but I'm going to try to answer it. And the answer is going to be yes, Freud was right about that. I need to just briefly introduce aphasia. Aphasia is difficulty in language production or comprehension resulting from some sort of damage in the brain. It's an acquired disorder. It's not a developmental disorder. It can happen from relatively benign conditions. So in this case, this is from the internet. This person actually gave permission where a newscaster developed aphasia from a migraine horror. As you know, for those of you who have migraines, you can have sensory effects. You can also have motor effects. You can even get a temporary aphasia from having a migraine. So this is just a recording of a newscaster on TV who is at some sort of awards ceremony. You know, she's got a local. I'm here at this award ceremony, and we're seeing all sorts of celebrities. Not that she's trying to say, but she suddenly develops a transient aphasia. So, the recording you'll first hear a man's voice. That man is the main newscaster who's turning it over to the other newscaster. And so this is just an example of aphasic speech.
And backstage coverage we're seeing for the very first time. Serene.
Well, a very, very heavy rotation tonight. We had a very Darrison, let's go to Terrace Chase English for the bit, the head of the pit.
Now, I realize that it supports sympathy and things like that. This is transient. It's not a problem. She's laughed it off. But imagine you should have your sympathy for those who have this on a relatively permanent basis. It is quite debilitating. So how do we think about this? Our idea, if Freud was right, if aphasic speech errors are just on the same continuum as just normal speech errors, if we were able to make a model that accounted for normal behavior, and that's what I've tried to do, and we were also able at the same time to say what would happen if you had lost all of your lexical knowledge. So if your lexicon had been disconnected from your mouth, but you could still produce phonologically legal syllables in your language, what would your errors be like? So we define this, and we call this the random point, or the point of total breakdown. Our theory says that aphasia would exist on a continuum between those points. Now, I haven't told you about what the space is like or how many dimensions are in that space, but that's the Freudian idea, that it's just a continuum between those points. So how do we do this? So we take our model, our computational model of everyday speech errors, and lesion it in some way, damage it. And there are lots and lots of ways you could do this. And so what I'm going to show you is the way that we think is the best, the way that we think captures most of the data. And we call this the semantic phonological weight hypothesis. And the idea is that you have connections between semantic features of lexical items, here indicated in red, and you have connections between lexical items and phonological segments, here indicated in yellow, and that these can differ in strength. Of course, they differ for lots of reasons. They differ depending on how common a word is and things like that. We're just talking about averages. And the proposal is, and we call the strength of the mapping at the semantic level, the semantic parameter, or the S weight, and with the one down here, the phonological parameter, or the P weight. And the theory is that people with aphasia have reduced S weights or reduced P weights. So there are two dimensions that can describe aphasia in this theory. So how do we test this? Well, we just need a lot of data. We got this by having a number of patients and a number of unimpaired controls, name a large number of pictures, and looked at their errors. So the pictures are all things that are it's really obvious what they are. This is a cat. Nobody else says anything except cat. Or if they say something else, they were trying to say cat. And we can look at the errors. So we're going to categorize the errors in these 6 categories. Correct responses like cat, semantic errors like dog, formal errors like map, mixed errors like rat, unrelated word errors like log, and non-words like death. And the first line shows you the proportion for age-matched controls. And you can see this is a really easy task. They get the 98% correct, and if they make an error, I know that doesn't add up to 100%. There's a thing called rounding that makes that happen. But their errors are either semantic or mixed. You don't see other kinds of errors. This is what you see in picture naming error patterns with people who do not have an impairment. Now, I've put up 3 patients. And I've given them names from the traditional ways that people refer to aphasia categories. LH is a conduction patient, IG is an anomic patient, GL is a Wernicke's patient. You might have heard the term Wernicke before, or the other term that's often used is Broca. And they have very different error patterns. Particularly the conduction patient makes a large number of non-word errors. That's typical of conduction. Whereas the anomic patient makes a large number of semantic errors. That's typical of anomia. But in general, I just want you to see that there's a lot of variability in what the patients give you. Can we account for that variability? What we do, these are just the same numbers that I gave you before. What we do is we try to make the model behave like the patients. We do that by varying the semantic parameter and the phonological parameter. So this is a search in parameter space. Try to make the model, so there are 2 what are called free parameters, the S parameter and the P parameter. And so we try to make the model behave like the patient. And so, well, first of all, you have to make the model behave like the controls. And with the S value at 0.067 and the P value at 0.0, these values aren't going to mean anything to you, but bigger is better. The model acts exactly like the controls do. For the patients, well, we can make the model behave like the patients, as long as we vary the parameters. So LH, the first patient up here, has a low value of the P parameter, phonological parameter. They have a mostly phonological deficit, and that explains why they're always saying things like dat instead of cat. Whereas IG has a low value of the semantic parameter. That explains why they're making many semantic errors. And GL, who has the Wernicke's patient, has kind of a low value of both. Basically, GL made a whole lot of different kinds of errors. So that's just 3 patients. I want to show you how well the model works, but I first sort of introduce a little graphic notation for how to do this. Is along the x-axis we have those 6 categories of response type, and on the y-axis we have the deviation between the patient and the model, and each patient is a line. So if there are no deviations, everything should be at 0. And you can see that these lines are pretty close to 0, so that's good. And so here are the deviations for the 94 patients. And this is all of the patients in the sample. And it's pretty good. They're clustering around 0. There are some patients that do have a significant deviation, but the deviations are not large. This 2-dimensional model, variation in the semantic parameter, variation in the phonological parameter, is accounting for a lot of what you see in aphasia. So notice that we're not talking about different kinds of aphasia anymore. We're not saying Wernicke's, we're not saying conduction. We're just treating it as these parameters, these Freudian parameters. If you want to know the different categories of patients, you can put them into this space. So here we have the semantic parameter on the x-axis, the phonological parameter on the y-axis, and up here in this high area, that's the controls. And you can see that the different kinds of patients cluster somewhat around the area in the way that people normally would expect. So for example, conduction individuals are thought to have a phonological deficit, and you can see they have all the conductions are the green circles, or whatever that color is. But they all have a low value of phonological parameter, but their value of the semantic parameter is all over the place. We recently have tried to apply this model to the brain. You all know about that you can try to map cognitive abilities to the brain through things like fMRI, or more recently, other techniques like optical imaging and things like that. With regard to impairments, you can ask which regions of the brain, if they are damaged, how that predicts particular symptoms. It's called voxel-based lesion symptom mapping. And in our case, instead of predicting symptoms, we're going to try to predict model parameters. So the idea is, well, this isn't real data. This is just completely made up. But it might be the case that people who make lots of semantic errors tend to have their damage back there. This is totally bogus. You did it wrong, okay? But and so on. It might be that the different error types associated with different parts of the brain. But that's the idea, to try to find that. And here's what we found. This is work largely, the leader on this work was Myrna Schwartz. The semantic weights, and I realize this is a left hemisphere. I know it looks like a right hemisphere, but there's something silly about the way that people make these graphs that I don't understand. This is a left hemisphere. And what you can see is the semantic weights associated with the temporal lobe. Basically, medial temporal lobe more anterior than posterior part. That is, having a high or having a low S weight is associated with damage in that area. The phonological weight is different. There's the phonological weight. Up there in parietal cortex mostly, somatosensory areas mostly. And so for now, I want to make a couple of points. First, I want to show you that the semantic and the phonological weights are totally different. Oops. Let's get this right. See, it's right. semantic phenomena. See?
They're different.
Oops. And the second point I want to make, for those of you who are interested in this sort of thing, Wernicke's area is not involved in this. Wernicke's area was not one of the areas that predicted damage at all, surprisingly so. We have a theory about this, and I'm happy to address the change in that question. For now, so we've got this model that respects Freud's ideas about prediction. About continuity. We have applied the model to try to make predictions about these patients. And I've got everybody, actually, today people have been talking about prediction, or in this room, Tanya talked about prediction, the role of prediction and explanation, and everybody's got a good quote about prediction, how hard it is. There's Niels Bohr. Prediction is very difficult, especially about the future. Let's go to Freud. Freud is always trashed for not making predictions. He's always trashed for having his explanations be postponed. Whoops. Wait, I'm not doing Freud. I just wanted to show you one example of where we've been using predictions. We're trying to use these parameters to predict recovery in aphasia. You might have heard that people with aphasia don't recover. That's wrong. They do. Even patients with chronic aphasia, they get better. They learn. They adapt. They improve, sometimes considerably. We can test this by testing people at a certain time and then retesting them, say 3 months later, 3 months after that, and so on. And we can track their recovery using these parameters. So here's a typical example. And one thing that we found, a very strong association, is that the value of the semantic parameter is a good predictor of whether there will be recovery. So here's a 2x2 table. People who have a low value of the semantic parameter or a high value of the semantic parameter, and then whether they recovered or didn't recover. It's a strong relationship. High value of the semantic parameter is correlated with recovery. A low value is correlated with no recovery. So for example, here's somebody with a low value of the semantic parameter. Over time, there's no recovery. Parameter values don't change. Here's somebody with a higher value of the semantic parameter. Over time, the semantic parameter gradually is climbing and climbing. It's an interesting question whether it can pull the phonological parameter with it. I don't know the answer to that question. I'll say as well, the phonological parameter does not predict recovery at all. Okay, back to Freud. I told you, Freud has been criticized because his theory doesn't make predictions. Well, he did make a prediction about speech errors, and I love this. He says, here's his prediction. It's the only one I could find. I really do not think that anyone would make a slip in an audience with one's sovereign, king or queen, or in a serious declaration of love. And then he goes on to say, it's in those situations where you're fully engaged, paying attention to what you're saying, you will not make a slip. Very reasonable prediction. Is Freud right? Yes, he's right again. Paying attention reduces slips. I realize that this is that everybody was already betting on this being the case, but it hasn't really been shown. Bonnie Mazzari and I just did the simplest possible little tongue twister experiment. We gave people things like chip, chill, chin, chill. They just had to say chip, chill, chin, chill, chip, chill, chin. Whoops. And we did various ways of making them pay attention to one of the words. So in one case, we told them accent the word. In another case, we told them don't make an error when you say this word. We even did things like say this word really softly. Anything that singles out the word. And we compared it to a condition in which nothing has been singled out when we looked at the slips. If a word is focused, so gin, in some way, you say don't make an error on this, or stress it or something, you get a certain error rate. And the other words suffer, the words that are not focused. And when there's no particular attention to any word, it's in the middle. So, Freud was right. Paying attention reduces slips. We actually put this into I was reminded watching John's car this morning that we tested language production in a car, in driving, driving simulator. You know, everybody who does driving simulators does experiments with cell phones to show that when you're talking on your cell phone, you're a bad driver. We flipped that. We asked, if you're driving, are you a bad talker? And you are. If you're a bad talker, you leave stuff out, you're more likely to make errors, and you don't remember what the other person said to you. So, Freud was right. Paying attention is important. Okay, now we get to the meat of the matter. The real Freudian part of slips. The Freudian part of slips. Almost invariably, I discover a disturbing influence from something outside of the intended speech. The disturbing element is a single unconscious thought which comes to light through the special blunder. Freud is basically saying all slips are Freudian. In fact, if you read the Psychopathology of Everyday Life, it is simply a list. Here are the main slips I found. And every single one of them is a Freudian slip. Or at least Freud uses a Freudian slip. His support consists of after-the-fact interpretation of a selected set of slips. It's selected because people brought the slips to him. They said, "Herr Professor, I've got a good one for you." So you can see there is this after-the-fact work. So here's an example. Patient says, es war mir auf der Brust so schwer. This is my attempt to translate it literally. It was to me upon the breast so heavy. So schwest is the first syllable of the word sister. And so it looks like the person has started to say sister instead of the word breast. By the way, this is actually an idiom that I think means I was depressed. German speakers? I hope. But Freud interpreted this person had an unconscious concern about his sister in some way. And it took advantage of the fact that the word schwer there, if you take that and sort of blend it with Brust, you'll start with sister. So that's Freud's way of thinking about speech errors. Doing this. Is Freud right? Not as far as we know. There's no clear evidence for the Freudian part. People have tried. People have collected unbiased samples and looked for Freudian influences. So a big paper by Ellis was one. And there's a really clever experiment done out here in California in which Bernie Bars had people say things like ig pout and Kerker Bane. These are things that can potentially spoonerize into food-related items like Burger King or Pig Apple. And they reason that some people are going to have repressed food thoughts and other people won't have repressed food thoughts. They assume that people on a diet would be thinking of food all the time and repressing those thoughts. And people not on a diet wouldn't. That's a great idea. I mean, it turns the idea of the Freudian slip into an actual experiment. Because we now have a prediction. You people have repressed food thoughts, you people don't. Now let's create a situation in which you potentially can make slips that express food thoughts. It's a great idea, it didn't work. Okay, let's go down the list. Let's see what we've got. I'd argue that Freud's theory says that correlation to the sort of modularity of the system. That is, through some sort of interaction, phonological slips express meaning. And that's true. Word slips, slips that occur at a higher level in the system, are influenced by phonology. That's true as well. That's the mixed error effect. Freud was right about that. The larger part of what I talked about here was presenting our model of lexical retrieval in a phasic speech to try to argue ultimately that the same sort of processes that generate errors in phasic speech work to generate errors in everyday speech. In other words, that there's a continuity between the normal and the abnormal with regard to aphasia. This idea was originally expressed by Freud, and Freud was right. And then finally, found a prediction from Freud, who said that if you are talking to your king or queen or making a serious declaration of love, or otherwise, what you're saying is something that you are fully paying attention to, that you're not distracted in any way. You won't make a slip. And more or less, Freud's right about that too. The final element on the list is the Freudian part. It's the part that gets everybody excited. It's the part that causes the press to ask Joe Biden why he said president instead of pope. Do you hope, the president is going to have a funeral, Senator Biden? That's the Freudian part. And I'm not saying it's false, but I'm also saying that there's no good evidence for it. So we cross that one out. No, we don't cross it out. We say no evidence. It's a difference. So what I want to do is I want to use the well-known saying, don't throw out the baby with the bathwater. It's a nice German saying that was in use in Vienna, only in Germany. What I want to do is the baby is the Freudian part. I want to throw out the baby. But I want to save the bathwater. The bathwater of Freud's theory, of the way that he talked about information retrieval, of the way that he talked about the relationship between the normal and the abnormal. But that's right, and that's consistent with a very dominant approach in cognitive science based on interactive activation, information retrieval. Interactive activation retrieval processes are extraordinarily popular in cognitive science. They dominate certain areas of many of the areas that I work with. These sort of models dominate. And in the last 10, 15 years, there have been attempts to relate interactive activation models to the brain, to processes whereby top-down information constrains more surfacey information in the brain, predictive encoding, all of these ideas come together. So I think that Freud is right about this. He's right about these ideas, and that we should celebrate him for getting something right. So I think that's just what I said. Spreading activation provides a mechanism for information retrieval. Interaction explains the effects of meanings on phonological slips and phonology on semantic slips. And this final part, which is the largest part of my research in this area, is that parametric variation in these spreading activation parameters explains the basic error patterns and the normal-abnormal continuity. Thank you very much.
Could you talk about perception errors, the flip flip side of production error?
Yeah,
This hearing, and whether or not this
Well,
plays out.
there is a large literature on that, somewhat smaller in the sort of natural perception domain. But because speech perception is studied maybe 10 or 20 times more often than speech production in this sort of domain, you get a lot of work on errors and things like that. So one of the speech perception errors are very, very, very strongly influenced by expectations, context, and things like that. But I'm glad you brought that up, because one of the current debates in the field, which is a really neat debate, I think, is what is the role of the phonological segment? What is the role of things like k? What is the role of things like k, ah, t, phonemes? Do they exist? I mean, there's an entire theory of phonology that says there are no phonemes. It's called articulatory phonology. It's a very, very, very important theory. All we have are gestures. We don't have things like k. These are things, they're vestiges from alphabets. They're not real. I think one can defend the idea that there are phoneme-like things in language production that maybe not in perception. And one of the things that you see in production is that you actually see phonemes pretty distantly apart exchange places. So take the case of, instead of saying left hemisphere, the error, this is from Vicky Fronkin from way back when, heft lemisphere. Where did that come from? By what mechanism did you do that? It must be, when you're trying to say left, that there was an H somewhere. And that H came out instead of the L. And here's the neat part. That L said, what about me? I need to be spoken to. Look, there's a place for me here. I'm going to go there. You could actually create sorts of things, these sorts of things by, once you select something, you inhibit it. So it's called post-selection inhibition. Take it, and the thing that wasn't spoken, in this case, the L, it wasn't inhibited, so it comes out. There is nothing analogous to this in perception errors. You never see exchanges like this in speech perception errors. So that's actually support, I think, for this idea that maybe there are like segmental-like things in production, but not in perception. And for those of you who know, so Greg Hickok down south, that's exactly his view. Segmental, he associates segmental things with somatosensory cortex. And but auditory cortex, so and somatosensory cortex is uniquely used in speech production.
If you hear what you want to hear, is there more of a baby in misperception?
Well, yes, that's a good. I'm not willing to call it a baby if you hear or produce what you want to hear. Well, everybody knows that Joe Biden wanted to be president. And wanting to be president causes the concept of president to be more available. There's just no evidence that it's a repressed thing that comes out. And so that's how I would take your point there. Yes?
I'm curious how you calculated the weights for your graphical model of the...
Yeah, so the weights, this model here, and the other model, is not a model in which the weight parameters are learned. It's not a model in which they're trained from a particular corpus. It is a free parameter of the system. And all the words in the model are given the same weight. So, of course, in real life, each word is going to have different weights, depending on frequency, recency, these weights come from learning in some way. But in this model, it's simply a free parameter. Now, so then it becomes a question of a parameter search process. And for those of you who know about finding parameters and things like that, two-dimensional searches are easy. It's pretty trivially easy. So this is not a hard problem. But one thing that we do is that we set the parameters based on their error behavior in one task, use it to predict their behavior in other tasks. So in one case, we can actually generate what are called parameter-free predictions. If you give me all the errors that you make in picture naming, I can assign you values of the S and T weights, and then I can predict your error behavior in a word repetition task, so where you hear the word and say it. So that's a parameter-free prediction. So this is just, it's a optimization process with respect to the naming data. So basic answer to your question. Yes.
The tongue twister task.
Yes.
Did you do anything to ensure that people were speaking at approximately the same rate?
Yeah, it was paced with a metronome.
Okay.
But of course, you know, they differ in that case. And it might be of interest, we didn't look at this, it might be of interest of whether the one they're paying attention to, whether it comes out early or late. Certainly, you know, when you have people do musical performance, if a note is important or emphasized in some way, you get some performers that will actually do it late, some will do it early, and you know, their expression affects some. Yes.
I'm curious on how, when you think about languages and how it fits all of this, especially in instances where people who know more than one language, trying to find the right words to use in the language they're working or they're using, might kind of
Yeah, and there's a lot of work on this. No one has actually, that I know of, made exactly this model, a bilingual version of this model. But there are bilingual interactive activation models. There are a number of those out there. But in production, one of the very interesting phenomena that is actually predicted from this is called the cognate facilitation effect. So let's take the case of Spanish and Catalan. Since I always use cat, gato is cat in Spanish, and gat is cat in Catalan. These are different languages indeed. They are. And that words that are shared phonological segments are always produced more quickly in picture naming tasks. This model would explain that in terms of as you activate the segments of one word, you're also activating, when you retrieve a particular word in one language, you're in part retrieving the word in the other language. The activation converges on common segments, so there would be an assumption that the gap is shared, and so it comes out faster. Now, one of the features of this model that I didn't talk about is how do you select words? So when you produce a word, you have to select it and say it at the right time. So there has to be a decision process to select the word. And when you're bilingual, so you have to have a thing that I call the grammatical traffic cop. The grammatical traffic cop has to say, I need a noun now. Now I need a verb. So it's like the traffic cop says, verbs hold up, nouns. Now you, like that. And there's something that's doing that. And that traffic cop, that's why nouns replace nouns, verbs replace verbs in speech errors and things like that. At the level of the bilingual, there has to be a language traffic cop. So Catalan stuff. And the way that we actually implement this is by having units that say bias all the nouns. I'm going to send a little bit of activation to all the nouns. Or now I'm going to send all this activation to all the verbs, which then combines non-linearly with activation from meaning to engage in the selection. With the level of multiple languages, I assume it's a similar thing. And for those neuroscientists, I think this is frontal. I think Broca's area is involved in this. But yes.
How would you model repression in your framework?
I would model it as simply either a reduction in the weights to a particular unit, or as and sometimes in models like this you can have a bias or a resting level of activation that's reduced. The actual process of repression, that is what causes you to want to repress something, no model like this can explain. This model is not at the level, doesn't deal with motivation, and repression is a motivation. Now there is We have another version of this model, a learning version of this model, that does do, quote, inhibition. So that if you retrieve the word cat, when you retrieve the word cat, you partially activate dog and rat. But the right answer was cat. And so what happens is that you have to decrease the weights from the meaning to the wrong answers, dog and rat, increase the weights to cat. And this creates what is analogous to, psychologists will know what I mean by this, retrieval-induced forgetting, or semantic blocking, or semantic inhibition. Is that repression? Not in the Freudian sense, but it is a sense of making something less available because of what you wanted to do. Thanks very much.